Okay, getting ready for STAAR. We're on TEK A.10E, which is about factoring trinomials. Let's quickly review some vocabulary. A trinomial is what you see in the question, where there's 1, 2, 3. There are 3 terms separated by addition or subtraction signs. And a binomial would be an example right here, where there's 1, 2 terms separated by an addition or subtraction sign. So there are 2 binomials in this answer choice. And we compare that to the next question, where there's only 1 binomial in the answer choice. Those are the 2 main types of these that there are when we're talking about factoring. This first kind is the easy kind, because even students, the way the question's asked, we're supposed to go from a trinomial and break it down into a binomial with 2 parentheses. But most students are better at going forwards, distributing the 2 binomials and ending with your trinomial. And when the answer choices are given with 2 binomials, typically students think that's easier, and we're going to solve it that way on this one. On the next one, you won't be able to do the distribution because we don't have both of them, so we'll have to go the backwards way. All right, on this first question, let's go ahead and distribute since we have both binomials. X times x is x squared. Then we distribute the first term times the last term. X times 3 is 3x. It's positive, so we put a plus sign. Then we distribute. We're done distributing the first term, the first letter, the first term in the first binomial. Now we're going to distribute the second term, the second number. Negative 20 times x is negative 20x. Negative 20 times positive 3 is negative 60. We have 2 like terms in the middle right here. So the x squared stays like it is. Positive 3x minus 20x gives us negative 17x. They cancel since they're opposite, and there's more negatives, so it stays negative. Minus 60. And we see that is indeed what the question was asking. So A is the answer. Taking a look at the next one, like we said, we can't use that same strategy using our answer choices. So we're going to have to take this trinomial. We see it does have a leading coefficient. So this is the most ugly kind of these trinomials. Let's go ahead and dig into it. We know that we are going to set up our x factor over here. The number that goes on top is the first term times the last term. The method we're going to use to solve this is factoring by grouping. 21 times negative 20. If you're not sure what that is, you could pull up your calculator. But the answer is 420, and it's a negative 420 because that's a negative 20. And then we take the middle term and put that on the bottom. And remember the question we asked her, what 2 numbers multiply to give us that top number and add or subtract to give us that bottom number? Now, this is where it gets particularly nasty because it's such a big number, 420. Most students this age can't figure out what the factors are, so you could get your calculator and just start multiplying numbers. You could do, or dividing. 420 is the number. You could try and divide it by 20. Well, we know that that's what we multiply to get it, so 20 and 21 would of course be factors, but 20 and 21 only have a difference of 1. We're looking for a difference of 13, so that won't work. So we need numbers that are further apart. We could do 420 divided by, and you could just keep going up and down the list from 20 to 19, but you get a sense of which numbers would work, which numbers wouldn't work. Of course, you could try and go menu, number, and factor. Let's see, 420, enter, and see a factor tree. So you could try multiplying 3 times 5 and getting 15. Let's see if 15 is one of the factors of 420. And there's all sorts of tricks you can end up playing, trying to go back and forth. It's guess and check for a lot of students. Divided by 15, enter. So we have 15 and 28. What's the difference between those? Okay, it's a 13 difference between them. So let's take a look back at this question. We want it to be a positive 13, we said 15 and 28 for the two numbers. 15 times 28 would give us 420. And we want, when they are, one of them has to be negative because the original number was negative. We need, when they're added together, we would need it to be a positive at the end. So the bigger number needs to be positive, so the 15 would be negative. Then we remember, as we write, we do 21x squared plus, and instead of doing this middle term, the 13x, that's what we just broke into parts, so it's 28x and minus 15x, and the order of those two does not matter at all. It could have been negative 15x and 28x, and then the last number stays like it is, negative 20. And this is called factoring by grouping, so we group the first two and the second two, and we try and factor out a common factor. 21 and 28, what number can they both be divided by? Well, you know it's a 7, and they both have at least one x, so we can take out an x. 21 divided by 21 divided by 7 would give us a 3, and we only took one of the x's out, so it was x squared. There's still an x left. Plus 28 divided by 7 would give us 4, and the x is gone. We see there are both negatives in this next one. They're both negative, so we can pull out a negative. And 15x and 20x, they can both be divided by 5. When we do that, there's a 3x, and 20 divided by 5 would give us 4. The next step, we take the first coefficient in front of the two parentheses and create its own group, 7x minus 5, and we see that the two parentheses are the same, 3x plus 4. And so we check our answer choices. This one was close, but it's minus, so that doesn't work. 7x minus 5, B is the answer. Those don't work. So we see that was tedious. You see why most students prefer going forwards and distributing rather than going backwards from a trinomial to the binomials. This one was one of the harder ones because of how large the top number in the x factor was. Nonetheless, let's move on. Here's another one that we are not able to do binomial distribution. However, it's not as hard because when we distribute, we're not going to get a giant number like 420. Let's go ahead and do our x factor. 9 times 1 is 9. The middle number, negative 4, goes at the bottom. What two numbers multiply to give us 9? Add to give us negative 4. Well, the factors of 9 would be either 1 and 9, or 3 times 3. And with 1 and 9, I cannot get a negative 4, adding or subtracting. And with 3 and 3, I cannot get negative 4, adding or subtracting. So none of that will work. There are no real factors. Take a look at the next one. We see that it is another problem that has a leading coefficient. We could distribute, and we could do the x factor. But since the answer choices have two binomials, we can always go ahead and distribute to find our answer. I'm going to go ahead and start on C. So I'm starting on C because I know that's the answer from having done it. This is the one downside for using your answer choices and distributing. If you're slow at distributing, it can take you time to get to the first one, the second one, and then figure it out on the third one. So if you are good, if you're efficient at doing your x factor, you only have to do one set of work to get your answer rather than doing multiple answer choices. But if you can't do that, if you don't know the steps, this distribution is pretty straightforward. 2x times 3x would give us 6x squared. 2x times 5 would give us 10x. 1 times 3 would give us 3x. 1 times 5 would give us 5. We have common terms. 6x squared stays like it is, plus 13x plus 5. That is indeed what the question gave us. The answer is C. Next question is another one where we can distribute to move forward, or we can x factor it. On this one, if we distribute, 1 times negative 30 is negative 30. Negative 13 would be the number at the bottom. What two numbers multiply to give us negative 30 and add to give us negative 13? That, of course, would be 15 and 2. Since it's a negative when we finish adding, we know the bigger number has to be negative. So it would be m minus 15, m plus 2. The answer is F. So you see, the x factoring, especially when the leading coefficient is 1 or a small number, doesn't have to take a lot of time and can still give us the correct answer. Since there were two binomials, we could, of course, have distributed. All right, next question. Which expression is a factor? We see that we do not have the two binomials, so we have to do the factoring. What number goes on top? Well, we take the a term and multiply it by the c term. 18 times 2 is 36. The middle term, the b term, goes on bottom, negative 15. What two numbers multiply to give us 36 and add or subtract to give us negative 15? And you could do some guess and check on your calculator, but it could be 12 and 3. 12 times 3 would give us 36. But when we add them, we want them to be a negative 15, not a positive 15. So we would put a negative for both of them. And that would be because a negative times a negative gives us a positive 36. But when I add a negative and a negative, it gives us a negative as well. Since it has the a term there, we're not going to go straight to the answer choices. On the previous problem, we went straight from this to the answer choice because there was no leading coefficient. On this one, we write it down, 18x squared. We don't do the middle term. That's what we just broke down. Minus 12x minus 13, not 13, minus 3x. And then the last term stays the same, plus 2. And then we factor by grouping. Let me make that middle one closer. That negative sign goes with the second group because it's applied to that 3. Now we try and factor out the common factor. 18 and 12 both have in common a 6 and an x because they both have an x. 18 divided by 6 would give us 3, and one of the x's is still left. Negative 12 divided by 6 would give us a negative 2. The x is gone. Since I want it to be a positive 3, when I take out of this next one, it's a negative 3 right there, but I want it to be a positive 3 because remember we want the two parentheses to match in order for factoring by grouping to work. So I'm going to pull out a negative 1. That would leave me with a positive 3x and turn that positive 2 into a negative 2. Now it matches 3x minus 2, 3x minus 2. That's what we're wanting to have happen. So we remember the two coefficients become our first one, 6x minus 1. And the binomial pair that matches becomes our second one, 3x minus 2. So we have our two factors, 3x minus 2. Matches here. A is the answer. This next one, we could do the x factor again, or we could distribute, and see if it works. We could work our way through all of these. At that point, we would find out that none of them work, and we would get our answer. Moving on to the next question, it asks for the expression. We do not have the binomial pairs, so we can't distribute. We'd go backwards. Oh, wonderful. We love when it doesn't have a leading coefficient other than 1. So when we do our x factor, it's going to be simple. 1 times negative 6 gives us negative 6. And then negative 5 goes on the bottom. What two numbers multiply to give us negative 6 and add to give us 5? Negative 5 rather. Well, sometimes students think 2 and 3, but in this case, if it's going to multiply to give me a negative, only one of them can be negative, either the 2 or the 3, but when I add it, if one's negative, one's positive, I will not end up with a 5, so that won't work. What are the other factors of 6? 1 and 6. And if I want it to be a negative 5, which one of those would have to be the negative? The 6, the bigger one. So we would have x plus 1, x minus 6. That is not, x minus 6. A is the answer. Here's another one where we can go distributing through our answer choices because we're given both binomials. I'm going to go ahead and start with B. 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. Negative 5 times 2x is negative 10x. Negative 5 times negative 1 is positive 5. We have common terms right in the middle. 6x squared minus 13x plus 5. That indeed matches. B is the answer. And that is the TEK factoring trinomials, A.10E. Good luck.